housekeeping notes. Please make sure your phones are on vibrate and silenced. You may take photographs of the session, but if any of the speakers asks you not to, please refrain. There will be recordings of the programs and the sessions on the website after the annual meeting. General social media policy for ABRF is that everything can be shared, but please respect any speaker requests that you not share their photo, their slides, or anything else. We will hold questions till the end of the session, and then hopefully we'll have a little bit of time for a robust discussion. And that includes our lightning talk speaker as well. Hopefully all of you have downloaded the ABRF meeting app. You can access the lightning talk abstracts. Don't forget to play the ABRF game, and you can rate sessions on the app as you go. And then there will be, of course, the annual meeting survey that comes back. So, welcome to this session on creative core staffing and using graduate students in the course. We have a great lineup of speakers, including a couple of graduate students themselves, so you can hear their perspective. So we've got an administrator's perspective, a core director's perspective, and the grad students. But we're going to start with our sponsor presentation. Udayan Umapathy from Volta Labs is going to be giving our sponsor talk. He is the founder and CEO of Volta Labs. Udayan received his bachelor's and master's from Purdue University, which is my home institution, and then his PhD in media arts from MIT. So he's got a lot of breadth there. So he'll be talking to us about some of the work that Volta's been doing in genomics, workflows, and sample prep. So I'll turn it over to you.
Awesome. Hello, everyone. My name is Udayan, founder and CEO of Volta Labs. Maybe some quick housekeeping from my side. Definitely feel free to take pictures, social media encouraged. Volta Labs. So we're up and coming startup. We're about 45 people located in Boston. When we started the company, we set out to change how sample manipulation is done. I'm here and excited to talk about how we can enable you all to do more with less. And in particular, sample prep is starting to become a big bottleneck. And we've launched commercially a new platform at AGBT this year that allows you to go from sample to sequenceable molecules pretty much for any available commercially available sequencing platform. So the platform that we've launched is a small benchtop platform. I'll show you that in a little bit. It comes with fully programmed applications that are ready to go. What that means is you're not developing any software, you're not developing any methods on this machine, you're not optimizing liquids, chemistries, temperatures, and so on and so forth. You're loading raw biological samples, for example, things like blood, tissue, saliva. You can take it all the way through library prep, target enrichment, and have molecules that are ready for sequencing. For short read, long read, you can name any of the commercially available platform. And it's you load your samples, you get molecules, you're ready to go. So how do we do this? So over the past 5 years, we've engineered this piece of technology that I'm showing you now. This is sort of at the heart of what we do. These are little droplets being manipulated on a surface electrically. So we can precisely position them, merge them, and we can also gently mix them. And this mixing operation is necessary for accelerating and achieving good efficiencies with enzymes. When you work with lysates, those are very viscous fluids to manipulate. And sometimes when you're handling high molecular weight DNA, for example, for long reads, you'll have to be very gentle with it. And so this is a pipetting and contact-free mechanism for mixing these fluids. Traditionally, this is done with vortexers, pipetters, and so on and so forth. The system does use traditional technologies like this one, a pipetter, to transfer the fluids into a little sort of reaction chamber, if you will. And what you're seeing here, these are, again, little droplets. This is about 40 to 50 microliter. The black particles that I'm showing you here, those are paramagnetic beads. What I'm about to show you next is a DNA extraction workflow on the platform. We use the non-contact mixing mechanism, and what you're seeing here, this clear fluid, this is cell lysate. The dark particles, these are paramagnetic beads. And so we use the mixing and keeping the fluid down using electric fields to let the DNA collapse onto the beads. And so what happens is once the DNA is collapsed onto the beads, you can see these really long strings. So these are long pieces of DNA that you can actually see with your naked eye on the platform. And so once the DNA is on the beads, we then programmatically introduce a magnetic field that pellets the string into a little disc. The disc is then sort of pulled out, and the supernatant, the clear fluid is sort of disposed of. And of course, this is a shot of what happens inside the machine. The system is capable of processing up to 24 samples, and these are little droplets. And let me pause here for a second. The white piece of plastic that you see here, so that's the cartridge that allows you to process samples anywhere from 1 sample to up to 24, and it provides you batch level flexibility. And so we took all of this sort of powerful technology and packed it into one platform. So the image I'm showing you here on the left side, this is the benchtop platform. As I mentioned, it allows you to go from extractions, raw biological sample, carry out extractions, library prep, provides batch level flexibility. And some of the reactions we've gotten from people who've used this is it's very simple to set up. It takes roughly about 15 minutes. Key highlight of the technology is the significant reduction in plastic usage. On an average, because of the way in which we manipulate the samples on the surface, it's almost entirely pipetting free. In many of these sort of sub-steps within a reaction. And so on an average, there is at least 10 times reduction in use of plastic. And we also miniaturize many of the workflows. And that results in significant reduction in reagent usage for workflows like library prep. And so at launch this year, we're introducing 3 lines of products, Volta Pure, Volta Prep, Volta Hide. The Volta Pure line of products allows you to isolate nucleic acids, DNA, RNA, short read, long read. The library prep piece allows you to carry out library preps. And if you are doing target enrichment or sort of any other sort of targeted workflows, exome panels, so we have Hype Capture as the workflow. This year we have launched and we have applications available for isolating DNA molecules from blood and cell lines. We will be announcing applications for isolating DNA from tissues, saliva, and so on and so forth. Under the Volta Pure umbrella, so we have applications available for isolating long pieces of molecule, high molecular weight DNA extractions, as well as short molecules for any of your downstream short-read sequencing workflows. As for library prep, we do have the PacBio library prep available on the system, and it comes miniaturized. I'll talk about that a little bit. And similarly, there are other methods available for short-read sequencing and long-read sequencing. And sometimes you may require bead-based methods. For example, if you just want to clean up or carry out site selection. So those are available as separate modules on the system as well. All of the data for all of these applications that I talked about is available on our website, and also happy to talk about that in person. So I wanted to talk about a few key areas where people have benefited from the Callisto sample prep system. Dr. Bobby Sabra, who runs a core lab at Mount Sinai, had an interesting challenge. They had a challenge in scaling up long-read sequencing, particularly for human whole genome on the Revio platform. So they needed a method that requires minimal training. They had staff on their core lab who had no training in how to handle high molecular weight DNA. It's a specialized sort of set of methods that requires whiteboard tips and careful and gentle handling of molecules, and it's a very hard process to scale up. And they also wanted a method that allows them to go beyond a handful of samples and continually run the Revio sequencer. And lastly, they needed a way to keep the cost on a per sample basis low, so they can be competitive relative to other service providers. And so what we did with Sinai is allowed them to actually accomplish all three. In the image I'm showing you here, the sort of the cartoon on the top demonstrates sort of going from cell lines to high molecular weight DNA. We took a range of molecules, a range of samples through the Callisto sample prep platform as well as manual. All of this data is published on our website, but the key highlight being the hands-on time was roughly about 15 minutes. What you get at the end is highly pure, long molecules with consistent yield. And from a variety of samples here at cell line, but we've done the same thing with the blood and so on and so forth. And if you look at the cartoon at the bottom, so that's the library prep workflow. You can take sheared molecules from Megaruptor or Covaris G-tubes, and the Callisto sample prep system, with about 30 minutes of setup time, it automates the entire process, starting from post-shear cleanup to library prep that involves detailing, adding the adapters, nucleus treatment, and you can also carry out site selection on the exact same platform. And so if you think about the infrastructure required to carry out this workflow in a traditional method, you need many, many machines. You might even need electrophoretic-based, gel-based cassette to do the site selection and several other devices to carry out sub-steps within the workflow. And so it's significantly streamlined. And and most importantly, what does the data look like? The key highlight being we took these molecules through full-scale reactions as well as miniaturized reactions. These miniaturized reactions used 1/3 of the actual volumes that you would typically use from a reagent standpoint. Even when miniaturized, you could use the full range of DNA without any loss in yield and sequencing quality on the HiFi sequencer. And the second use case I wanted to talk about is at the Broad Clinical Labs. The Broad had an interesting challenge where, if you think about the Broad Institute, it's an institution that's existed for the past 2 decades and has played an important role in genomics. And they've managed to scale up their automation that can process very large number of samples in very large batches. But with the speed of sequencing increasing and with batch level flexibility available on several new sequencing technology, there is a need to, for them, there was a need to process small batches of samples rapidly and for many chemistries. And so what we've done and showcased with the Broad is we've allowed them to go from blood to library in under about 4 hours for short-read sequencing as well as for long-read sequencing. Technicians who have had no experience doing library prep extractions were able to operate the machine and carry out and produce very high-quality molecules that feed into a sequencer. And similar to the use case with Mount Sinai, here we've used about 1/3 of the typical reagents you would use for short-read sequencing. Most importantly, the Broad was able to actually get clinically relevant mutations in genomic variants from these molecules. And one important aspect that stood out, so this is a reaction from the Broad, is the system actually required far fewer touch points relative to a standard liquid handler. And that's something the Broad is particularly interested in. But also, if you take a step back, the system that's available on the Callisto platform allows you to run many applications and provides batch level flexibility, and that's something that's resonated with the Broad as well. So all of this data is available again. The Broad talked about this at AGBT, and this is data that's available on our website. So super excited, super thrilled to be announcing and have this platform be available. Given how simple the system is and with the batch level flexibility and reduced cost of operating the instrument, we're super thrilled that it's available on the market. My colleague Nick, John, and I will be here at booth number 615. Happy to talk to you more and take any questions if there are.
Thank you. That video was super cool. All right, where is where's the HDMI port here? On the top? Am I missing it? No. That's not the HDMI either. The HDMI is right here. Oh, now everybody's awake. Everybody's awake. All right. Thank you. I think our next, we have a lightning talk by Shishua Huang, am I pronouncing that right? From Baylor College of Medicine on advanced technology research education for secondary school teachers. So I'll see if I can't bring that up. No, that's the right one. It's just not. It's not the one that's showing. There we go. No, that's the wrong one. Are they all pulled up? There it is. Okay. All yours?
I'll just advance over here, right? Thank you. So we have designed a training program for middle and high school teachers in using the resources in advanced technology course. And the program include a hands-on component, the teachers working in the core facilities. In the past 2 years, we had 2 or 3 weeks program. So the teachers, we use the model showed over here on the right. So we do post and pre and post program server, and then we use a hypothesis-driven model, so teachers will go through the whole process, but exposing to the technologies. We divided the program into 3 components. Seminar series, that's module 1, and the core facility hands-on training, that's the majority of the time spent in the core facilities. And then the session, the module 3, we have literature papers related to the technology training, and then the STEM specialists that work with the teachers to try to come up with a specific lesson plan for their classrooms. The right-hand side is a workflow for one of the technologies that they use in my core lab, using antibody-based proteomics array technology, working on the identifying markers among different subtypes of breast cancer. So the teachers extract the proteins in the lab and then spot on the protein array, go through image analysis, scanning, image analysis, and data analysis. And the survey data showed pre and after the program survey showed that teachers all have increased confidence in their knowledge and abilities. And also they enhanced their understanding in scientific research. So each of them, the last day of the program is a presentation day. Actually in the morning normally it's working on their presentation. In the afternoon they show their lesson plans, what they're going to bring to their classrooms. They had been working over the last couple of weeks. And the right-hand side, it's one of the 9th grade teachers developed a lesson unit using public available data to develop a heat map or analysis workflow and with questions and heat maps generated by the students. So the 3 of the 7 teachers in the 2 years program is a pilot program by a grant, internal grant. So they could make a lesson unit. The other 4 teachers normally is because of the schools do not actually allow the teachers to do extra work if they are the core teachers. So and that's what's the program about. Thank you.
Thank you. So I am going to turn it over to Karolien Denef. Karolien is the director of the Analytical Resources Core at Colorado State University. There we go. And we'll talk to us a little bit about how her core, or series of cores, uses grad students.
Okay, hi, I'm Karolien. I am a core director at Colorado State University, go Rams, and I am excited to talk to you about grad power. So the power of graduate students and how I love employing them to work in my core facility, and I hope I can convince you or at least inspire you to explore this creative staffing mechanism at your own institutions as well. How do I proceed here? Let's see. So I've been doing this for many years. I have been employing graduate students since I became a core director at CSU, and I tell you, it's been a lifesaver for me. Really helps me overcome challenges that I'm faced with when I'm in times of staff shortages, when people leave for other positions, and where we have sudden gaps in the services that we provide to the users. And they bring tremendous benefits, not just to the core, but to the users we serve, as well as the graduate students themselves through the professional development opportunities they gain from working in the core facility. Many of you here, I'm sure, work at universities where you have this incredibly talented pool of graduate students right at your fingertips. They're right there, and a lot of them have probably already experienced working in your core facility as users, and they're easy to employ, so use them. I've employed probably 24 graduate students since 2016. And I have very much enjoyed working with them. So in fact, some of them stay, and they can be very interested in applying for some of the positions that you may have had vacated because of staff leaving. And imagine all the time you save on onboarding and training new employees, because these students have maybe worked for you already 6 to 8 to 12 months. So in this picture, actually, those are 2 of my staff scientists. On the left is Rebecca Miller. She is actually at ABRF for her very first time. And Alyssa Winter-May on the right. They both started out as graduate students back in 2020. We had to hire some students under COVID because we had some staff shortages because of early retirements. And now they're actually working full-time in the core. Alyssa actually works in 2 core facilities, so she splits her time over my core and another core. So a little bit about my core facility. It is called the Analytical Resources Core. This is the majority of my staff. It's a large group. Over on the third from the left is Bradley Gilliams. He's a current graduate student. He's actually here in the audience. Maybe he can answer some questions for you. We hired him to help develop some biological applications in our electron microscopy lab, which was historically really focused on chemistry and material science. And Bradley had that experience from working in his own research lab. So we brought him in because we were interested in developing that as a new service offering, and before hiring a full-time person, we just decided, let's bring a graduate student in and explore this potential offering in the future. It's a large group. They're responsible for 45 pieces of high-end analytical instruments, and we have services that cross a lot of different technologies. Our services are organized in 3 service centers. We have a molecular and materials analysis center that's really focused on chemical structural elucidation, materials characterization, so that's where you find our NMRs, EPR, mass specs, some spectroscopy, materials analysis techniques. We have an X-ray crystallography and diffraction lab there. Our imaging and surface science center is focused on high-resolution imaging, electron microscopy, electron diffraction, and lots of spectroscopic techniques to look at chemistry and surface properties of materials. And then we have a bioanalysis and omics center that's really focused on mass spec-based quantitative, qualitative metabolomics, proteomics, metaproteomics, adaptomics, ionomics, you name it. And they have a lot of bioinformatics tools there as well. So big lab, big facility, everybody works extremely collaboratively. Hold on. So as much as I want to believe that my core is the best core in the world and nobody's ever going to leave my group, I do have staff turnover, and I'm faced with a lot of staff shortage situations. So I hope you never have to bring your own kid to work when you are in those situations. This is my son. He's 15 now. He's not as cute as anymore as he's in that picture. But he enjoyed working for me, and I'm like, well, if my own kid can help out in the core, then I think graduate students would be really great to plug in. So typical staff shortages that we're faced with are when people take, we breed talent at universities. It's no news to anybody here. At a certain point, they're going to go and take positions elsewhere at much higher pay than I can afford. Sometimes it's because of lack of career opportunities within my core facility. I don't always have the best career ladders, and sometimes people look for better positions at a certain point in their career. So I can't hold them against that. And I'm actually always proud that they find positions somewhere in really great companies or at national labs. It's really hard to find skilled staff to replace those positions when they're vacated. So that's always kind of a problem in the moment. We tend to hire junior staff, and they learn a lot on the job. Sometimes faculty bring in new equipment, and the core facility is the best place to house that equipment because it has a shared use. But boy, all of a sudden you have that new beast of an instrument, and who's going to take it on to work on it? So that can be sometimes a challenge. Searches take forever. In my case, it's between 6 to 10 months before I can hire a new person, and I don't always have the authority. When a person leaves a position, I have to go through a whole route of approvals and justifications why I have to get that position filled again. So I have a little bit less control over that, but what I started focusing on is how can I overcome that 6-month period of a gap in the services, which can be very disruptive in our operations. So I hire graduate students. These are some examples of some students that have worked in my core in the last 5 years. Like I said, I've hired 24 graduate students since 2016. Dominic was hired as a chemistry graduate teaching assistant. He started helping out when we were under COVID. Our facility is mostly self-service, and all of a sudden students were home and we had to continue our services, so we provided full service, and for that you need a lot more staff, so we hired a graduate student to help out there. Rebecca Miller stepped in when we had our surface scientist go to a reduced effort, and then he actually took an early retirement, so we hired her as a graduate teaching assistant from chemistry. Alyssa stepped in when we lost our NMR lab manager, was the only NMR expert in my facility. Took 10 months to replace him, so thank God for a graduate student, so that's where Alyssa stepped in. Autumn and Finn just recently started working in the facility when I lost my X-ray crystallographer. That search took 8 months. And then Bradley, like I said, he stepped in to actually develop new applications where I wasn't quite ready to develop a full service offering, and I wanted to explore that offering first through a temporary employment. They fill in all kinds of roles. So what they do in the facility can range from general lab operations, where they help with SOPs or lab inventory, or they help with iLab, or they do system verification scans on instruments. Sometimes they do full service work. They collect the data for users, they process it, they interpret it, they write the reports and communicate with the customer. Some of the students work on new application development, like I mentioned, what we're doing in our biological EM, and some of the graduate students actually train and teach other graduate students, so they're actually teaching their colleagues to work on instruments. Benefits to the core, there's a lot of them. I feel like graduate students bring fresh perspectives. They are plugged into the research, they're doing it themselves, so they're very aware of the latest research developments. They're very easy to hire. I don't have to go through long approval routes and justify. I just work with the account manager in the department, and I say, hey, I want to pay them. They're cost effective, they're dedicated. Sometimes if you have teaching activities in your core facility, a lot of these graduate students have had to teach for the department in their graduate teaching assistant roles. So they have a lot of teaching experience, and it's a gateway into core employment. I've hired several graduate students to work now full-time in the core facility. Benefits to the graduate students themselves, I think if you ask any of the ones who have worked for me, they all will say it's the hands-on experience that they gain from working with instruments, not just the instruments that they use for their own research, but any instrument that's available in the core facility that they have an interest in, we encourage them to help out and work with that technology. They learn to be professionals, they have to communicate with customers, with students. They learn to even have difficult conversations with difficult users. They get a lot of mentorship in addition to their own professor. They get mentorship from us. They learn how to collaborate and be part of a team and a community. So here's one of my students who wrote a little testimonial, and I can't even read this myself. Working in the ARC has provided me with invaluable hands-on experience with instrumentation that I otherwise would not have had access to. It is an absolute pleasure to work with such a great team to help provide training, instrument maintenance, and education to a broad user base. The skills that I have learned in this role have allowed me to grow as a scientist. Who wouldn't want to hire her? Benefits to the users, well, they're graduate students, so they know graduate students. They know what they're going through. They're empathetic. Battery. They can be innovative. They're colleagues to the users. They can be very flexible, and it actually turns into a cost saving for the faculty who we help pay for a shared effort from the users. So actually the faculty benefit from this as well. So how do we go about hiring students? Well, in the past, my core facility was actually part of a department, and in that situation, we used to get graduate teaching assistants from the Department of Chemistry. They had an effort of 20 hours a week, and their tuition was covered by the tuition tokens, and their stipend was actually covered. My core actually moved a couple years ago into the research administration arm of CSU, so now I actually work more with graduate research assistants. We have a little bit more flexibility over time. I can kind of choose with the faculty how many hours they can work in the core. It could be 10 hours, could be 5 hours a week, could be 20 hours a week. I help pay the stipend from my recharge operations account. The tuition is a little bit harder. Tuition has to follow the stipend, so if I take on a full-time GRA, I have to pay the tuition, and that can be tricky because you can't always pay tuition from the recharge accounts. In fact, you can't in my case. So we have some central support to help with tuition payments, and I'm really hopeful to work with my administration to see if we can get tuition tokens funded through our graduate school, through something called a graduate service assistant, and then we wouldn't have to worry about those tuitions anymore. And that is all I have. Reach out with questions. I think we're going to have questions after the talks. Love to grow my network. I'm also, together with Natasha, the PC chair for next year's 2025 meeting. If you're interested or have some ideas for sessions, come find us. And if you do chair a session, you get a t-shirt. So there you go. Thank you.
Well, I'm just going to skip my talk because what she said. No, we use, at Purdue, we use graduate students very, very similarly, which is why I made Karolien go first. So I will try and keep it short to give some of our other speakers a little more time. So my name is Natasha. I am the Associate Director of Operations for the Bindley Bioscience Center. We have 7 core facilities that I manage administratively. The ones on the left in the gold, all of them are currently using or have used graduate students as staff in the past, or are currently using. So one of the challenges that we face, like many of you, our cores are either understaffed, which means our people are constantly running, or they're solo staffed cores, which means there is zero backup if something happens. We had a core director go out on medical leave for 6 weeks recently, and if that happens, the whole core shuts down. So there are no backups for emergencies. If we have, for instance, in our metabolomics core, we had a PI come to us and say, I'm gonna get a major grant from the DOE next year. It's gonna be like a 3-year grant. I am going to send you 2,000 samples like every month for the next 3 years. We don't have the staff to handle that on top of our usual workflow. It's just not gonna work. The other problem with being understaffed or stretched as we are is that we don't have the bandwidth to develop new things. Like Karolien was saying, one of her graduate students is kind of working on some new methodologies. Our staff usually doesn't have the time for that. They're just running with people's samples. And that's a problem because you need your course to stay cutting edge. You need them to stay up to date. We had faculty coming to us and saying, hey, I'd like you to develop this method. Can we take the time? And the answer was always no. And what ends up happening, your staff gets burned out. If they go to industry pays them twice the rate, and now you're more understaffed than you were. So we also started hiring graduate students to fill those gaps. It started about 8 years ago. Our imaging facility director left. It was a solo staffed core, and there was nothing. And it is a, use it yourself core, but we had nobody to train. The microscopes weren't being kept up. Things were a mess. And so one of our major users said, hey, I have a graduate student. If you'd be willing to take her on and employ her, she could help out. And that worked so well that we just kept doing it. So we do use graduate students to fill short-term gaps. Just like Karolien, it takes us 8-10 months to fill a staff vacancy. So we employ graduate students either for one semester or a year at a time. Special projects within the core, sometimes we have specific things that need to be done, and I'll show you a use case here in just a minute. When we want to test drive new services, again, very similar, we're not really sure if we have the user base, maybe this will work, maybe it won't. We hire a graduate student to do it for us, and then if we can prove that we have the user base and that it works, then we can fully integrate it and maybe hire a full-time staff member to do it. Often when we need to cover a surge, or sometimes when we're just feeling understaffed, because graduate students are so much easier to hire and don't require a long-term commitment, we can show, hey, we've used this graduate student in the core for 2 years, 3 years. The need is not going away, and it gives us data to go to upper administration and say, hey, look, I've got 2 graduate students in the core at 20 hours a week. They've been here for 2 or 3 years. The need isn't going away. Can I have a full-time staff person now? Our upper administration won't show us that, won't let us do that without data. And then we have a few where we have long-term TAs or RAs where that 10 or 20 hours a week is just what we need. We don't need a full-time staff person. And recently we launched what we call a collaborative method development program, which is a little different. We're not hiring the students directly, and I'll talk about that a little bit. This is what our imaging facility location looks like on the south side of campus. We are a distributed facility, and our imaging director came to me at some point and he said, I am never in the right place at the right time when somebody needs something. Whoops, sorry. Hit that. He said, anytime somebody needs my help, I'm always at the other location. So we have a 20-hour-a-week graduate student TA in this core facility who works long-term. Like, we just replaced her because she graduated, but she was there for 3 years. Sorry, I'm not sure what this thing is doing. So she was there for 3 years, which was great. And when she wasn't helping students, she rewrote all of the protocols and training manuals for the core, which was fantastic. They desperately needed to be updated. She was writing it from a grad student's perspective who had been trained in the core. So that gave us a really nice update for the core facility. Special projects in the core. Our mass spec core had a lot of instruments that were old, that were broken. Some of them were no longer supported by the vendor. We have mostly Agilent instruments in this core, and we have a really good relationship with them. So they actually told us, okay, here, you've got this triple quad, it's broken, we'll just give you all the parts because it's so old, good luck. So we had a grad student, this is Tom. Tom is a grad student in the chemistry department, but his first love is instruments. We begged his PI to give him to us for a semester, he agreed. And during the course of that semester, Tom rebuilt pumps. He got that triple quad working, that Agilent didn't think could get working. We had an old GCMS that we brought over into the core facility. He repaired it. He trained the staff on how to operate and maintain it. And rebuilt 2 pumps on a QTOF that even our instrumentation repair people were like, I'm not sure this can be done. Well, he did it. So I don't knock your grad students. They have expertise that you would not believe if you find the right ones. We were so profoundly grateful. So we were down 5 instruments, and now all of them are working. 1 semester of a graduate student. Launching new services. Nick Morato, who's at the top there, also at ABRF, is actually going to be speaking in the imaging mass spec session. This was a PI who had developed a high throughput screening and bioassay method from a 5-year DARPA grant, and he wanted to take this methodology, which was very unique, and offer it as a core service. This lab had all of the expertise to run it. So we agreed initially that he would support the grad students and the core would support the time for the grad students to train our staff. And over a 3-year period, we have slowly taken it on and have been able to evaluate the effectiveness of this workflow and evaluate the user base. And now the core has it fully, but we've kept the grad students because they are still the experts in this technology. And even though we have core staff who can run it now, the grad students are just, I mean, they're there, they know what they're doing, they're the experts. Veronica on the bottom has now taken over from Nick in that workflow. So we will keep them on, and we will keep graduate students working. And I've got another grad student in another core facility who's working on a cross-core workflow. She'll start in August. Again, we're going to evaluate this service. We'll see what it looks like. We'll see if we have the user base. And the nice thing is, if it doesn't work, you've committed to that graduate student for a year. They don't expect any more. There's no permanent expectation of permanent hire. So if it doesn't work, you can just let it go. One of the things that we really struggle with was time for method development in the core facilities. University administration doesn't necessarily see non-billable time as valuable, even though we all know that it's absolutely crucial to keep your core up and running. And we would have faculty come to us and say, oh, I need this method, or my student needs you to develop this for their dissertation work, but also it's kind of a high-risk situation. We're not sure if it's going to work. The faculty's not willing, my grant's not going to fund 6 months of work without knowing if this method is going to work. So we developed a collaborative method development program. The PI pays their student the same as they usually would. The core facilities, and this is actually from central funds, I have a central funds pool that I've set up for this, will cover instrument time and the necessary staff time to mentor the student, to troubleshoot, to help them out. Proposals are submitted by the faculty for a 1 or 2 year term, and then we all work together to develop these new methods for the core. And this could be something like the second harmonic generation imaging. It's not necessarily brand new. Other cores have it. We didn't. We needed to develop it and develop the workflows on our scopes, right? Same with the metabolic flux analysis. We had a grad student work for a year. She worked with our biostatistician. She worked with our core directors. Now the core has that workflow. So the grad student gets what she needs in terms of her dissertation work. Now the core has a new method. And that has been very successful. I've got an additional 3 projects that we just funded this year. So this has been a great way to collaborate with graduate students, and it's been very much of a win-win situation. Pros and cons. Grad students can be hired for short periods of time if you need them for that. They're often your core users. They already know what they're doing. They're trained in core protocols. There's a very low administrative burden to hire them. Again, like Karolien, there's no hoops to jump through. You just go to the department and say, I want to pay your grad student for 6 months. And they often do have specialized expertise. You'd be very surprised. The cons, there is high turnover. Like if you're looking for a long-term hire and those TAs turn over every year or two, that can be a difficulty, which also means that there's some frequent retraining. Luckily, because they're core users, that training time is pretty short. They are only available part-time. If 20 hours a week is all you need, that's great. But at some point, you're starting to hire 2 graduate students to cover a full-time position. Temporarily, that actually works. Like I said, it gives us good data to say, hey, we need that full-time position. And remember, they're also working on their own dissertations. I mean, like any other RA, they have to balance the needs of the core facility with their own work. And so as I asked my core directors to be aware of that, right? I mean, it's easy when you've got a really great grad student to say, hey, can you do this? Can you do this? Oh, how about this? And can you do that? They need to have time for their own work in their own space. Whoops. So these are some of the grad students we've hired over the years. We've also hired 24, 25 graduate students in the past 8 years. They've all been absolutely wonderful, and we could not have done it without them. So thank you very much, and I will turn it over to Victor Young, who directs the X-ray Crystallographic facility here at University of Minnesota. All right. All yours.
Thank you. Hello, I'm Vic Young from the University of Minnesota, Department of Chemistry, and I'm going to talk to you a little bit about our staffing of our X-ray crystallography lab. I'm basically here just to introduce my graduate student over here, teaching assistant, Alex. He's going to tell you a little bit more about what he does and why he likes to work with X-ray crystallography. So I thought I'd introduce the subject of X-ray crystallography, specifically single crystal diffraction, because this audience does a lot more biological and medical related materials. So molecular structure by X-ray crystallography is sort of the center of this orbit here, the nucleus of an atom you might think about. And it's sort of touched by 5 unique areas in science: geology, biology, chemistry, physics, and mathematics. All these sort of feed into it. If you go to look for a school to learn about X-ray crystallography or powder diffraction, they don't really exist in the United States. There's a couple of programs around the world that teach how to do crystallography and actually give that discipline, but there's very few of them. So people like myself have learned this sort of on the job. I was trained as an inorganic chemist, organometallic chemist in graduate school, but I really loved X-ray crystallography. So these magenta colored fields of science here all feed into X-ray crystallography, but then you can see the various second orbit of sciences. So biotechnology, protein engineering, drug design, neurosciences, chemical product development, material science, nanotechnology, forensics, mathematical physics, earth science, paleontology. All these fields benefit from X-ray crystallography. This diagram came from a workshop that we did for the U.S. National Committee for Crystallography in 2005, and I was happy to be on that for 2 terms and 3-year periods after that. So X-ray crystallography, what can we learn? I mean, the most important thing is to know the 3-dimensional crystal structure that you're working with. If you don't have that in our area of small molecule science, you don't know what you're working with. It's very important. So, what's a compound? What's a formula? If it's a known formula, what crystal form is it? Geometrical details, you want to know bond distances, bond angles, how things are distributed in space, how things pack together is very important. And then, what's the relationship with other known structures? We have the Cambridge database, which covers a lot of materials in small molecule crystallography, organic, organometallic. We can go to that as a resource to see whether or not we made the same thing. That just happened to me recently. I got sent a couple of things that turned out in the database. Not interesting for us to look at. Once we have these materials, can we control or adjust the packing? And we look for phase transitions quite often too. So So this is our science. I've had the pleasure of having some exceptional TAs in the past few years. Margaret was in our lab for 2 years before Alex has been here. Alex has been here for 2 years. So she's gone on to DuPont, standing in front of the instrument. She's holding the gopher here. And then Alex and Eric here, current TAs. Eric was in our laboratory last summer while Alex was over working at Vertex in Boston. So 3 wonderful TAs all learning how to do single crystal diffraction work and teach that. So our core facilities at the University of Minnesota Chemistry Department are the traditional ones that we have. Nuclear magnetic resonance, mass spec, single crystal diffraction, and I don't really need to discuss this with the various people here. You all know these various cores and what they do. Our mass spec lab keeps on getting new instruments. The most recent one, or maybe the second most recent one, is a mass cytometer. That's probably of interest to several people in this particular audience. But we have a good array of mass spec instruments. Joe DeLay here has been in our facility for about 10 years and just keeping it going very nicely. New hire for us 2 years ago is Tom. He's been doing a great job here. We have a good array of instruments. Some of these are directly for teaching, and many of these are for research too. So, we have to balance this research and teaching for all these different courses that we work with. And for my laboratory, we have basically one instrument now. So we've had this for 10 years. I guess we're at a point now where we have to think about updating this. But this has been a wonderful instrument. We have microfocus optics here. We have big detector. We can do hundreds of data collections a year and publications from this. My laboratory is primarily single crystal diffraction and the X-ray crystallography that comes out of that. However, we have a course for teaching graduate students how to do their own single crystal diffraction work, and that's where working with Alex is sort of key. I teach the course, but he does most of the laboratory interaction, and then after the course is over, he's spending a lot of time with the students making sure that they keep on track. So the roles of teaching here. In mass spectrometry, we have a TA who's responsible for training on the EI instrument. They also do some additional work for maintenance and that sort of thing. But they have a part-time person responsible for maintenance, and then we have a core director. In NMR, there are 2 TAs, and of course NMR is one of these facilities where there's just a lot of more hands-on work because you have to replace the cryogens on a weekly or monthly basis, whether it's liquid nitrogen or liquid helium. So they have 2 teaching assistants for that. Tom is a new father, so he was gone for 6 weeks about 6 months ago. So the teaching assistants had to do all that work themselves, and I think he had to come in a couple of times to, work with them on that. Now, we're a little bit different in X-ray crystallography, and I think that's why, Alex is here to speak, is that my TA for X-ray crystallography has got to commit to a 2-year commitment for the laboratory. And there's just a lot of work that or a lot of knowledge that the teaching assistant has to glean as he goes along, he or she. And so the teaching assistant spends a lot of time working directly with the students as they are collecting their own samples. I do that too, but there's just a lot of work that happens iteratively, and people have problems. So we have a really nice microscope, a Leica microscope. I know they're here as a sponsor. And without that microscope, it's very difficult for us to find a good specimen to put on an instrument. So we've got a good polarizing microscope. We have to teach the students how to work with this efficiently. And Alex ends up doing a lot more work here for liquid nitrogen fills and those sorts of things. So there's maintenance work that we do too. So one of the benefits for Alex is that he gets to run service samples and complete the reports on these, and sometimes they get put in publications. So he did all this work here that I'm showing you on the right-hand side for these two slides here. So for this, the group, the Hoy group at in the chemistry department, the X-ray crystallography was actually sort of a minor part of this. They did all the synthesis, they did all the NMR work, they pretty much knew what they had for the materials. The X-ray actually confirmed that they had the correct materials. In this particular sample here, the lower one here, there's 4 unique molecules that are in what we call the asymmetric unit. So it's a more complicated structure. The second sample here is another one that, for a different paper that they were working on, a new synthon that they made. So Alex did the work for these. He's listed in the Cambridge database. He's actually doing the work. Thank you very much for your attention. I'm going to turn over to Alex.
All right. Well, I'm Alex. I'm, as Vic mentioned, the TA in the X-ray crystallographic facility, and we've heard a lot from the managers how great it is to be a grad student TA, and so now I'll give my perspective on it. So I'll go over fairly quickly. I'll just rehash the responsibilities of what I'm expected to do. Vic touched on this a little bit. And then what I really want to focus on is the benefits of this position that I've gotten. And so just in general, the TA is a year-round position. It's a 50% TA appointment, and so that means that I am expected to do roughly 20 hours per week. That fluctuates depending on whether we're in the busy season or the not busy season, and the primary responsibilities change as well. And during the non-class semesters, so this is the summer and fall semesters, I'm primarily responsible for basic instrument maintenance and supervision of less experienced users. Instrument maintenance takes roughly 30 minutes per week, and about 3 to 4 hours per week are spent supervising less experienced users. And during the off-season, and I guess really year-round, I'm able to run samples for untrained and external users, so Vic gave the example of the ones I ran for a chemistry group that doesn't have any trained users, so I run their crystals when they need it. Currently, I've run 26 samples for external users. As Vic mentioned, there is a class that's required by everybody who wants to use the instrument. They have to take it. And so this class entails both a laboratory and a lecture section. And as the TA, I'm responsible for the entirety of the lab section, as well as parts of the course section. So for the lab section, and this is the major responsibility for the class, we meet once a week for 2 hours. Each section has 3 to 4 students with 3 to 4 sections overall. And this meets for maybe the first 6 weeks of the semester. And this is where the students get their first hands-on experience with the diffractometer. And so I go through with them, how to use it. It's a bit of a process, lots of steps that they have to learn and keep track of. And this lab section culminates in the students independently collecting the data for 2 single crystals, and then they present on these crystals as their final project at the end of the course. And I'd say about 10 hours per week is what I spend doing the lab section. And that jumps up to 10 to 20 hours during the final project data collections. That's a course of about a month is definitely the busiest time for me as the TA. For the lecture section, the TA is responsible for grading all of the coursework, which is around 10 hours per week. On top of that, I hold office hours, which, depending on how difficult the material we're covering is anywhere from 0 to 5 hours a week. The TA is also able to give select lectures. So the TA always gives a lecture on crystal growth. And if the TA would like to give additional lectures, they can. And I am one of those TAs who likes to give additional lectures. So I think this semester I gave 3 lectures. And actually, as TA, I was able to innovate on this crystal growth lecture a little bit. And I added a hands-on activity where after I lectured to the students about how to grow good crystals, we actually go into the lab and grow some crystals. And this image here is of the crystals that the students this semester grew. And if they're able to successfully grow crystals, they can then use these crystals for their final project data collections. And it's kind of fun for them to see, the process from growth to completion of the structure. So those are the responsibilities. So what benefits do I get out of this? And the first one, and perhaps the most important, is experience. I have grown to be quite experienced on this instrument. I've personally collected and processed data on over 200 crystals. I've become proficient in several different software packages, ranging from single crystal software to molecular visualization software to protein molecular docking software. I've learned instrument maintenance and troubleshooting for both software and hardware issues. And I have personally, as of date, trained 20 new users on the instrument. Other benefits are networking. So I've met most everybody in the department through this position. Most of the graduate students, pretty much all of the faculty and staff, and many alumni. We have this picture here with Margaret. She was featured in Vic's slides as well. She's now a senior scientist at DuPont, and I wouldn't really have known her had I not been in this position. And I've also met people from other departments and universities as well, both in the local area and elsewhere. Another benefit is collaboration and then variety, just being exposed to a lot of different things. So my PhD work is synthetic organic chemistry, but through this position I've been able to work with many different fields, such as chemistry, pharmaceutics, material science, and physics, on a wide variety of projects. And I actually chose this image here to talk about a little bit. This came in 2 weeks ago, I think, and it is from the physics department, and it's actually a metal alloy that they're working on for superconductor research, and they brought it in, and I was able to work with them to help determine the crystal structure. And it was just very fun to be able to see something so different from the field I work in on my PhD. Another benefit is publications. So I currently am an author on 3 publications that is just directly from the work I have in the X-ray crystallography facility. I'm an acknowledgement on several other papers. And I'm currently working on a first author paper that if I was not the TA in this facility, I would not be able to do. And this involves taking a bunch of old chemical samples that were donated by a retired faculty member, and I'm collecting the crystal structures on some of those and, working to use these crystal structures to set up virtual protein screening for inhibition. And hopefully someday maybe finding a collaborator who can take these compounds and actually test them against protein targets. And I think the last thing I want to talk about is some of the opportunities I've gotten from this TA position. this talk is a great example of an opportunity that I would not have had I not been in this position. And through connections that I made, I was actually able to do an internship at Vertex Pharmaceuticals, located in Boston, and I worked with their X-ray crystallography team, and I was able to see how it's applied in the pharmaceutical industry. And we have a picture of downtown Boston here that is actually taken from my desk as the intern. As the intern, I had one of the best views, which was awesome. But overall, being a graduate core facility TA is a lot of extra work, but it's very rewarding. I've had many opportunities I would not have otherwise had, and it has really enhanced my graduate school experience. And I'll just give a couple acknowledgments here. I'd like to thank Polly, Alyssa, and Serena. They helped me stage some photos of me being a teacher that we saw in the earlier slides. I'd like to thank Karolien for inviting me to speak here. And of course, I'd like to thank Vic for having me as the TA. Thank you.
All right, everybody, we got some microphones in the middle of the room. We got some time for questions, so.
Thank you. This is fantastic. I have a question about I think it's for all of you probably. For the graduate students, what year are the graduate students normally? Because after the second year, the students have their own projects, the PI or the students will not be happy to work part-time in the core facilities. Is that so?
I guess I'll start. We actually do take graduate students in their second years, and sometimes they just split that work between their projects and their core work. And so far, the faculty have all been very happy to have them working in the core.
All right. So you maybe elevate some of the stipend payment or something like that, or the learning the core technologies. Why the PIs will be okay? That's my question.
Well, they do. Oftentimes, they're working. Their projects often heavily involve the core facility, which is how we find them in the first place. So they're able to kind of to make that split a little.
Yeah, and I will say, in my case, when we have for example, my X-ray diffraction manager left, the faculty are very nervous because that is the person that will make sure that the instruments keep running and are functional. And so sometimes it's also an investment in the core, like. I'm going to put my student in there because I know that they will make sure that services keep running, yeah.
Okay, thanks.
Yeah, so I may, I don't know if this is working.
Seems on, sort of.
I'll just talk loud. I'm a fourth-year grad student currently. I started the position as a third-year grad student. I know my advisor is happy to have me in the position because it means he doesn't have to pay me from grant money. And
That's a lot.
it's beneficial in that way.
Does that affect your thesis defense and the progress of your research?
I would say a little bit. I personally spend more time in the X-ray lab than is required of me because I like it a lot more than my thesis work. So it is by choice that I'm spending more time down there than I would have.
Oh, I see. So you're fully paid by the core. So the core director is okay with that. You do your own research project.
Yes.
Yeah, well, there are a number of students like Alex who don't have a lot of support for their research assistantship with their their PI. So it just happens that we have a nice opportunity for him to develop these other skills.
Okay. Sorry for all these questions. So how do you organize that in the university? So you have a totally organized program for the graduate students to apply, PI to apply, or just randomly searching people says, hey, you will be suitable?
It's not random for me because every teaching assistant who's worked in my laboratory has come to me and said, I'd really like to do that. And we haven't had to coerce anybody. Some of them have spent more time in there than I thought they should. But Alex has found a good balance for this because he is motivated to get his PhD and leave the University of Minnesota.
Thank you. fantastic talk. A couple questions for me are, what's the kind of spread you guys see between graduate students at a master's level versus a PhD level? And do you have a harder time with certain graduate students from certain disciplines or PIs kind of letting them go? We've tried to do this at my university, but we found that genomics and the biology departments, the biology faculty really don't want to share their students. So what do you guys have seen in those regards?
Go for it.
Almost all of our grad students are PhDs. For the long-term TAs, it just works better that way because we can keep them longer. We have not usually had an issue with faculty letting their students go. Our mass spec cores often hire out of the chemistry department, and they are usually very collaborative. I've gotten some out of the Department of Nutrition for our proteomics core. So it does depend on the PI, obviously, but for the most part, we find our grad students, because they're already working in the cores, and we have a very collaborative relationship with those faculty. So we reach out to the PI directly and say, hey, what do you think? And we've not had issues finding grad students.
And then what's the shortest stint you guys have had for some of these appointments? Do you have like short 3-month stints for like summer?
Yeah.
And
We've done
have
that.
you guys played around with like internship approaches instead of paid approaches?
My shortest has been a summer appointment, and then it's been a semester, and some of them have stayed a whole year. What was your second question? Internships.
Internships versus the paid appointments.
I usually just send an email out to all faculty or major faculty users to say I'm having a person leave, I need some help in the facility, and then they respond to say I have a student who could help out, and then I kind of screen and make sure that when we're in a pinch that I bring a student in that has already some experience in the facility.
Yeah, similarly, we've done summer, semester, 1 year, 2 years. We haven't done internships because the grad students need to eat, right? So we've always paid our grads.
Yep.
And it sounds like it's worth the investment.
Yeah, absolutely for
Yeah,
us.
and for me, at the University of Minnesota, most of these have been 2-year appointments, and then they've got their skills, they're going elsewhere. A couple times we've had one summer, one quarter semester, they would be there. One time I had a person for almost 4 years.
Mm-hmm.
I've had a couple for 1 year, and then they've made a transition.
And
So
then my
most time is 2 years, like Alex.
And my last one really is. I come from a university that has a lot of really one-person stat cores. And so trying to train a new person when you're also under huge workload, is very difficult. Having a grad student, I can see that there's a lot of already knowledge that's there. How do y'all handle, or there have been any tricks that help with single-staffed, overwhelmed cores in getting people trained and on board and set ready to go to take advantage of this without feeling like it's not something they can take on at the time? Any like tricks with getting going?
Yeah, I'm not sure I have any magic formula. The one thing I would say is you're training those people already to be core users, right? So that's half the battle. They're already halfway there. So a lot of it is just a little bit of additional of like, how do you manage to bill an iLab? Like, how do you train other people? So I would say 60% of the work you're doing anyway as a core director, just by training the user. So that's how I like to look at it anyway.
Yeah, and
For me, it's
sorry.
been, I'll say, well, we got to change this X-ray tube. You want to tear apart the instrument with me? And they love to do that. or we got to do something about the cryostat to fix it because it's not working. They love to do that sort of stuff.
Yeah, stuff you're doing anyway, right? It
Yeah.
has to be done.
Yeah.
Cool, thank you guys.
All right, I think we've got somebody in the back there who's been.
I just have one quick comment and 2 little questions. First of all, I'm with him. We've had pushback on this a lot. You go to the PI and they're like, oh, no, they're super busy. Don't bother us. That's my one comment. So I'm so intrigued about all this. But the 2 questions I have is I'm still not clear how you're paying them. If somebody could address that, and then I'll have a seat. And my last question is, does this prolong generally the time to get to the thesis defense? And if somebody could answer that, prolong the time they're taking to get their PhD in defense. And then If so, maybe is that a good thing? You know, they do an extra year or something, and all of a sudden they have a whole new skill level. If somebody could address just those little questions.
We pay our graduate students directly out of the core facility. Tuition is always the big question mark. At Purdue, students are not charged tuition. They are charged, graduate student, it's a stipend fee remission. And at Purdue, that is not considered tuition, it is considered a benefit. So we can actually cover that. I will let other people talk about times at graduation.
Yeah, I can answer that one, I guess. I already mentioned that I spend quite a bit of time in this position, not working on my thesis. And it is probably going to prolong it a little bit. However, I am also getting a lot of experience in a specialized field, and it's the field that I actually want to go into when I graduate. So getting all this additional training is worth it for me if it's going to take me an extra year to get my PhD. I'm fine with that because I'm getting trained in a whole different field.
And at CSU, I pay the stipend out of our recharge account. The tuition is always a little bit harder because we can't charge it to the recharge account, so we have some central funding to help with tuition payments. So that's how we pay him. I don't know if it prolongs the, maybe, he's graduating early, there you go. Yeah.
Hi, thank you. Maybe not quick question, but what advice can you give for core directors at university that would like to engage the administration, the grad students, the PIs to set up something like this? Like if you're starting from scratch, what advice can you give them?
So the graduate students are probably the easiest because, like Vic said, they come to you. They want to learn more. They want to be more engaged. And the PIs, it can be, some of them don't want to get involved. Some of them are thrilled to not have to pay graduate students off their grants. And they're also really happy that the grads are getting more experience. I think a lot of it is just getting the word out there, talking to the graduate students about the benefits of being able to do multiple projects with multiple different faculty. They really do get a wide range of experience and a wide range of disciplines. Our students say the same thing. So I would start with the students, right? Get them excited. Let them push their PIs.
I'm just curious. You guys have considered from grad student to technician sort of route, but have you considered the reverse direction where you look to find a technician with the skills that is interested in grad school and could then take that route, further to the PhD?
I've actually had a few junior level research associates who started out in the core and were pretty adamant about saying, I'm only going to work here for a couple years. I want to go to grad school, but I'm not quite ready to go. And they started and worked 2 years in the core and then started a PhD program. So it does happen. Nothing we, really induced or anything, but they were pretty upfront about that. And, we still had 2 years of a technical position that was filled by them. Yeah, and I don't know if it helped them to apply for grad school, but I think it did. It's really good hands-on experience that they have. They can start in a PI's lab that has a lot of instrumentation. They can actually benefit from the position to apply to grad school, I think.
Has anyone of you ever had a director supervisor have their own student work in the core, and would you allow that?
We do not. We actually just this year put formal policies in place that a core director may not have their own graduate student working in the lab because of conflict of interest reasons.
So if I'm understanding the comments from each of you, it sounds like the success has been found in having your grad students work on a fairly narrow set of instrumentation and somewhat of a more specific aspect of an instrument. Alex Kramer, operations manager for the University Imaging Centers. We've got about 10 staff, 60 instruments, and so there's high demand on each of our staff. We've thought about postdocs and graduate students, to be frank, but we haven't taken next steps. Where we're running into conceptually issues is it's one thing to teach the instrument, right, the technical aspects. And then it's another to pair with the biological background of 50 departments and the sample needs of each faculty. And so it gets us back to this, how long they're going to work for us as a core before they move on to their next. So realistically, 6 months lets us get that sort of introductory training level to them. And so I just, a long-winded question, but I guess in general, if you have any comments on how you've kind of approached that, and maybe it's a thing where single instrumentation or just narrowing that band that you're working with them on is the recipe for success. It might be that simple, but if you have any comment on that, that's kind of my question.
For us at the University of Minnesota, all my teaching assistants go through my class. So they've had the basic training, and hopefully they've gleaned some interest in the field, and they bring that with them to work as a teaching assistant. So we ask for 2 years. I think Alex would probably tell you, he's still learning stuff, and he's been there for 2 years. And you know, if he was there for another 2 years, he'd learn a bunch of new stuff. And whatever he learns in this environment, he's going to be able to take off. And a lot of that is not instrumentation. That is skill sets in crystallography and publication and graphic design. It goes off in so many tangents. So for us, that's been sort of the recipe. We have somebody who's comes in and we say, well, 2 years, and maybe he has more comments on that.
Yeah, I guess if I can clarify, sorry, I'm not at the mic. I don't mean to disparage the grad students or anybody in this process. It's just putting both parties in an opportunity for success. I don't want somebody to be overwhelmed by what they don't know, and that creates a challenge for the faculty who are using our core, right, as well as the staff who are assisting them in training and getting up to speed. So,
Yeah, I think for a longer-term TA, in our imaging core, we also ask for 2 years for some of those reasons, right? It takes time to spin up, and sometimes we just have a short-term need, and we need a very specific, narrow expertise. It helps in our mass spec cores that Purdue has one of the best analytical chemistry departments in the country, so the grad students come in with a whole lot of experience and expertise and training anyway, so the spin-up time is very short for them.
Hi, it sounds like you mostly cover the stipends of the students. Do you pay, is there anybody that pays, like, do you pay them like techs that they're replacing, or generally just keep them at the stipend levels?
We have to pay whatever their department pays them.
Yeah.
Okay.
Yep. Lunchtime.
Well, we went over with questions, but I'm glad there were questions. So it's lunchtime, everybody, so enjoy yourselves.